conference. This time, it is my privilege to serve as the Master of Ceremonies during this first session of the event. It is important to mention that the official language of this event will be English. As a means of providing our 18th World Lake Conference audience with an alternative event between the original and rescheduled dates, the organizing committee is hosting this pre-conference virtual event with a focus on natural and man-made lake sustainability challenges and solutions. Today, we have the honor of having the presence of Dr. Sergio Antonio Silva Muñoz, Provost of Academic Affairs of the University of Guanajuato, and Dr. Walter Rast, Chair of the Scientific Committee of the International Lake Environmental Committee Foundation. As the first point of our schedule, Dr. Walter Rast, Chair of the Scientific Committee of the International Lake Environment Committee Foundation, will also address an important message to the audience.
Okay, thank you, ladies and gentlemen. I want to say hello to everybody. I think we're all getting used to these strange virtual conference programs, and I happen to be a sort of a dinosaur where these things are concerned, but I'm here. I want to say good morning to you wherever you are, this being a global program. We originally thought we'd be with you in Guanajuato, but this nasty little COVID-19 virus changed pretty much all of our plans. But I do want to tell you that the 18th World Lake Conference has not disappeared. It has just been postponed until next November. And in many ways, I don't know if there's a good face to put on this, but it gives us now more times for further abstracts and special sessions for submission for discussion at the conference. And I also wish to thank all of you for listening in English. I'm sure that your Spanish and Portuguese so much better than mine. If I tried to use it, you would probably run me out of the hemisphere somewhere else because of my use of the language. In any case, we're also grateful to the University of Guanajuato for co-hosting this. It's going to be a very interesting World Lake Conference when it does take place. And in the meantime, we are going, the university has decided to go ahead and put this virtual event in place to sort of fill the gap between now and then, and also to keep your appetite sharp. Whoops, I locked myself up. There we go, appetite sharp. So we're going to have two webinars today, in fact. There's this one, in which we're going to talk about probably the most pervasive water quality problem on a global scale, which is eutrophication and some of its manifestations. And then this evening, which starts at this evening, I can't remember, it's 1900 at this time, so it's about 7 p.m. If you happen to be awake in the middle of the night and would like to talk about it as well. We're going to talk about another aspect of eutrophication, which is an interesting one, some practical applications for some of the consequences of eutrophication. There are going to be other events other than this seminar that are now being planned between now and then. By university and by other institutions. And I urge you all to keep yourself informed by way of the Guanajuato World Lake Conference 18 websites and the ILEC website, ilec.or.jp. It's quite simple, ILEC Organization Japan. For dates and topics to be covered, I think you will find those interesting as well. So in the name of the ILEC Scientific Committee, which I am very honored to chair, I want to welcome all of you, and I hope you're all find this as interesting and enjoyable as I think it will be. So with that, I guess I will say, let's shut up and we will get this show on the road. So welcome to all of you and enjoy this seminar. I know I will. Thank you.
Thank you, Dr. Walter Rast, for your message. Now, Dr. Sergio Antonio Silva Muñoz, Provost of Academic Affairs of the University of Guanajuato, will also address an important message to the audience.
Thank you very much for your kind introduction, Eric, and also I'm very happy to be here with you. On behalf of our university, the University of Guanajuato, I want to thank all the audience. As I have been informed, at this moment we have participants from 18 countries. So this is a very successful audience, despite in some parts of the world, for example, in Japan now it's 1 in the morning. So this is very important. We really appreciate your effort to be here with us, and also the University of Guanajuato hope that this pandemic will finish as soon as possible. I don't know, this morning I heard that Pfizer is almost successful in getting the vaccine for this pandemic. So that will allow us to have and shake your hand next year, in 1 year time from now. So I hope you will enjoy this webinar, but also I want to talk that we have been working with ILEC for more than 10 years. So the experience of implementing ILDM methodology in Mexico has gotten very good results on how to manage, how to deal with problems related with lakes, even if those are man-made or natural lakes. In this sense, I want to point out that the topic for the conference, that's governance, resilience, and sustainability of lakes, for sure will make us a better society. So now lakes have showed us how to be resilient. Now as society, we should be resilient to overcome this COVID-19 pandemic. In the terms of our university, we will be very happy to host this conference next year, and we hope we can see you face-to-face here in Guanajuato, Mexico, in our university. And we greet friends from all over the world. At this moment, we have participants from Africa, from Asia, from Europe, and from America, from North America, Central and South America. I want to thank also the conference, the keynote speaker, Sandra Azevedo from Brazil and Shinjiro Sato from Japan. They will present us very interesting and important topics about how to deal with problems related with sustainability of lakes, but also with governance of lakes, and will show how lakes are resilient to the impact of human activities. On behalf of the University of Guanajuato, we really wish, and we are sure that this pre-conference virtual event for the 18th World Lake Conference will be a fruitful one. Thank you very much for joining us, and we appreciate also all the contributions of the National Water Commission of Mexico, of ILEC, and the state of Guanajuato government, also to our friends of very, very diverse organizations like Mexican Network of Basins, but also I want to thank the participation of Corazón de la Tierra, the Environmental Institute. So I don't want to forget to mention any institutions, but I want to thank all those who are involved, even the organizing committee. Thank you for your effort, and I hope this will be a very, very fruitful and nice experience. And please, we will meet you. I hope we will meet you next year. Thank you very much.
We appreciate your important notes, Dr. Silva Muñoz. Now it's time to proceed with the following activities in our schedule. It is important to remark that this pre-conference virtual event will consist of 2 separate complementary sessions, each being 2.5 hours in duration. To accommodate participants in different time zones, one session will take place this morning and this evening, Mexico Central Time. Each session will comprise a keynote address, followed by a moderator lead panel discussion on the keynote and related topics. Participants also can submit relevant questions to the panelists and keynote speakers. Now, We will start this morning with Keynote Address. It is important to mention that you can express your comments or questions in the session chat, which will be collected by our team members to be shared with Professor Azevedo at the end of her speech. It is my honor to introduce our first keynote speaker, Professor Sandra Azevedo, who will be presenting the keynote address, Cyanobacterial Problems in South American Reservoirs, Historical Background, Current Status, and Prospects for Mitigation. Professor Sandra Maria Feliciano de Oliveira e Acevedo. She's graduate in Biological Sciences at the Federal University of São Carlos with a master's degree and a PhD in Ecology and Natural Resources at Federal University of São Carlos. Currently, she's a full-time professor at the Carlos Chagas Filo Institute of Biophysics at the Federal University of Rio de Janeiro. The main area of expertise is applied limnology, focusing on cyanobacteria, cyanotoxins, water quality, and effects on public health. 23 master's and 25 PhD theses were already supervised. She has published more than 19 papers in Indexes magazines, 1 book, and 12 books chapters. Consulting advisor of the Brazilian Health Ministry, the Pan American Health Organization, the World Health Organization, and the scientific and also she's a scientific member of ILEC since 2006. Professor Azevedo, you can start anytime. Thank you for being with us.
Oh, thank you so much for your introduction, Dr. Eric. It's a thanks for the invitation. It's actually a pleasure and an honor to be here as a keynote speaker of this event. I hope next year we can stay together and match each other in a real way. And I ask for the first slide of my presentation that is controlled by Roberto. Now, yes. Thank you so much. First of all, I would like to present my thanks for the organized committee. They are doing a great job. They are so patient with this old lady that doesn't have enough experience of this new system. Trying to do our best. These guys gave us a tremendous support. As you can see, I introduced Latin America in the title of my lecture today because we have done some survey about the Latin American situation around cyanobacterial issues. And I could not lose the opportunity to present the data that we about whole America, okay? So next slide, please. Okay, let's start to define what we are talking about. Cyanobacteria is a very old, ancient group of bacteria that appear in our planet around 3.5 billion years ago. So these gram-negative bacteria start to do a photosynthetic activity that allow the oxygen to be accumulated in the Earth atmosphere, to change our atmosphere. So we need to keep in mind that we are talking about someone, a group that stay here in our planet before anyone. Next. So we cannot be surprised when you realize that we can find cyanobacteria anywhere, any aquatic cyanobacteria, and even some environments. Cyanobacteria also can grow in extreme conditions, and they have specialized to be there and grow there. but also they prefer some kind of environment. We need to keep in mind that cyanobacteria didn't appear in a clean oligotrophic water. They up in our planet evolutionary process using a water like a soup, a high amount of organic matter nutrients. And they can be planktonic or so they can habitat any kind of different aquatic environmental in the water column. The next one, please. Okay. Also, we have a very diversity in different cyanobacteria groups. Diversity can be observed by the shape and cell size. The cell size can move from 0.4 micro until 4 micrometers. We have different ecology strategies. Someone likes highlight intensities, others doesn't like highlight intensities, and so on. And we have a high diversity in the production of metabolites. Okay, next one. If cyanobacteria is a natural component of phytoplankton, what's the problem? They are anywhere. What's the problem? Well, the problem starts when our anthropogenic eutrophication process changed the water quality, and this decrease of environmental quality, water quality, promotes the dominance of cyanobacteria. It's normal to have cyanobacteria and other phytoplankton organisms, but it's not good or normal only to have cyanobacteria. In this case, cyanobacteria could produce a high amount of cells that we name it as blooms. And these blooms can produce harmful effects for aquatic organisms or even for those that need to get water. They start with aesthetic problems. Nobody wants to show or to swim in a green soup, or can have taste in another that people start to reject that water when this water is used as a drink water supply. We can have oxygen depletion when this biomass starts to be decomposed, and then we can observe fish mortality. But the scenario, we have intoxication of animals and human beings by the presence of cyanobacteria in water. Next. Next slide, please. Okay. But we need to observe the reports about cyanobacterial blooms occurrence is not a new issue. There is already some proof in Europe, more than 1,000 years ago, someone made some report of cyanobacterial blooms occurrence. In some primitive people, we can have of traditional knowledge about this phenomenon, toxic blooms, since North America, Africa, and Australia. So we are living together with cyanobacteria for a long time. But we started to be more aware about this. Next slide. Many centuries after the first report, start to appear some technical reports about animal death by ingestion of cyanobacteria. It happened at the end of 19th century in Europe, or one of them, the most one in Australia. It's a turning point because the population starts to observe that they are losing animals that they need to have, so it represents economic loss. And then more attention starts to be done for this events, and more studies start to be done why cyanobacteria can cause the death of cattle and other animals that's in for humans. Next. Okay. At the beginning of 19th century, and we have already information about various cyanobacteria genera and species. A lot of species are able to produce different bioactivity metabolites. A huge of metabolites started to be identified. And some of the metabolites are classified as cyanotoxins, okay? And the cyanotoxins aggregate different kind of molecules that depends on the mode of action by pharmacology or toxicology point of view. They can be classified as neurotoxins, hepatotoxins, cytotoxins, or the classical LPS, lipopolysaccharides, endotoxins, that is for any gram-negative bacteria. Okay? The next, please. But according to the toxicity, the two main groups that are most studied and we have much more concern about are neurotoxins, that means they affect the neural system, and hepatotoxins, that the main target organ is the neurotoxins is a different class of alkaloids, different chemical structure, in different mechanism of action. We have the classic enetoxin A. Now the new name for enetoxin AES is guanetoxin, that is an organophosphate, and the group of saxitoxin, group of alkaloids that are also produced by ionoflagellants in the seashore area and marine environments. The hepatotoxins, the classes of cyclic peptides, the two main groups are microcystin with more than 100 variations and nodularin, okay? The cylindrospermopsin that in the beginning was classified as hepatotoxins is much more classified as a cytotoxin because we have enough information that this molecule can present effects, strong effects, different systems and organs. Okay? Today we don't have time to talk more about the toxicity and the chemical structure of this toxin. There is a huge information about that. The next opportunity we can talk about. Next slide, please. Okay. Where we have toxic cyanobacteria in Latin America. The occurrence of toxic cyanobacteria in drinking water supplies has been registered in some countries in Latin America, in Argentina, Brazil, Chile, Honduras, Mexico, Uruguay, and Venezuela. And when it occurs, it's not only an environmental trouble, it's also a public health concern. You have huge, as I am showing you by this picture, drinking water supply is a big challenge to be managed. Next. Also, some blooms can occur in coastal lagoons. That is another kind of aquatic environment so important for recreation, for fishing, and some countries have huge troubles and recovery troubles. In Argentina, Brazil, Colombia, and Uruguay, for example, have strong cyanobacterial blooms. In the tropical areas, this bloom can stay there all year long. It represents a risk for recreational activities, fishing, and so on. Next. Even the reservoir for multiple use also presents cyanobacteria. It has been registered in different countries also. So we have cyanobacteria bloom in this kind of reservoir. We can have troubles for irrigation because cyanobacteria can affect the vegetable irrigator with this water contaminated. We have problems to catering animals. We have troubles about recreational activities. We have about aquaculture activities, etc. So these can impact economic and environmental quality too. Next. And sometimes these blooms that started to be developed in a coastal lagoon can reach the littoral zone. So we can have problems at the beach. As we can see here, is a famous beach in Rio de Janeiro. Beach. Sometimes we have these blooms from Jacaré Lagoon enter for many kilometers at the beach. So we need to close the beach. We have problems for even they don't enter in the water, but the inhalation of this spray of this water can represent actually a risk for human health, of course, also for fishing activities. It's already been registered in Brazil and Uruguay. Next. I am waiting for the next slide. Okay. Let's try to understand what it happens so frequently in Latin America. Who we are? Well, our population represents almost 80% of the world population. We are 20 countries, and we represent 13% of Earth land surface area. Not so small. But according to some data from WHO, we are not managing well our water resource, mainly fresh water resource. We are not doing a good job in sanitation. Let me show why. Next slide. According to the survey, we can observe that we are not so bad. You consider that 65% of our people receiving a safe and managed drinking water service. Okay? We are in the average of the worldwide. But even that, we need to admit, we need to realize that around 20 million people are living without clean, safe drinking water in Latin America. It's not acceptable. It's not acceptable anymore. We have conditions to solve this trouble. And the next slide, please. When you consider wastewater treatment, the scenario is worst. In Latin America, only 22% of wastewater is managed. Okay, it can justify the increase or big part of the increase of our eutrophication process in our reservoir lakes and rivers. We are not treating our wastewater. It comes completely without any treatment to the rivers, to the lake, even for the water supply. So we need to much more attention about the sanitation service that we are doing. Okay, next. Okay. Unfortunately, these pictures are so common nowadays around some metropolitan area in in Latin America. I want to hear photos from Brazil, but I'm sure we can find similar photos in the metropolitan area in Latin America. It shows us that it's a social trouble completely linked with environmental trouble. We cannot talk about public health quality when you have this situation around our metropolitan area, how you can guarantee good drink water, like in this condition, good environmental health in this condition. Millions of our people are living in this situation. Okay, we know this. Next. Okay, but it's not eutrophication, the unique causes to justify the increase of cyanobacterial bloom. During the last decade, we don't deny anymore are facing streaming water events that come increasing any year. Okay, from now on, we needed to learn how to solve or how to manage extreme water events. During these extreme water events, or we have a strong drought season for long periods, no water for anyone, or we have strong rain, strong storm, and flooding. In both situations, we produce conditions to face cyanobacteria. When we have strong precipitation and the tropical areas start to be so strong in a short period of time, we introduce a high amount of nutrients in our water bodies. When you have a strong drought season for a long period, increase the water stability. Cyanobacteria likes stability in the water column. We can also increase the conductivity. This is also some examples how these extreme events can also contribute to the increase of cyanobacterial blooms in our aquatic environment. So plus eutrophication and extreme water events, we are facing some perfect conditions for long and strong occurrence of cyanobacterial blooms. Next one, please. Okay, just one example of this event. Every event is an event that is very well studied and known in Latin America, mainly in South America, I believe. I put some photos north in the site from a reservoir in northeast region in Brazil. We have El Niño events there. They stay sometimes 3 years, the last one was 6 years without enough rain. So severe drought season. We are doing that time more than 20 years ago. A project in a reservoir, 6 months later, the level of water in this reservoir decreased 18 meters. Then we have a soup of bacteria, and 6 months later, there is no water anymore to be studied. But of course, cyanobacteria has some mechanisms, some strategies to survive in this dry and as soon as the water comes again, they start to grow so fast. In the right side, it's an important river for Southeast River. This river supplies water for Rio de Janeiro metropolitan area and some big cities, other big cities, and we do so much the amount of water during other cycle of El Niño events. And we have, again, a soup of bacteria in this reservoir. Next, please. So, summarize. Eutrophication, anthropogenic eutrophication, mainly anthropogenic impact in eutrophication, plus climate change, we are producing a perfect scenario for and increased cyanobacterial blooms. So this cartoon is very well done. I love this. People that are able to do this kind of summary. It's publishing, it's not my cartoon. And it summarizes different impacts that we can do in environmental, aquatic, environmental, in lakes that justify the increase of cyanobacterial bloom. Okay? Next. Okay. But to understand the situation about cyanotoxin complexity in water and the relation of human health problems, we needed to consider the trophic cyanotoxin connection in this water, in this aquatic environment. It's not to imagine it, the connection with filtered organisms as zooplankton and then we have enough data that prove that fish and other aquatic organisms can bioaccumulate cyanotoxins from cells that they inject. And also other compartments of aquatic environmental also can be affected and bioaccumulate these toxins. And if these aquatic environmental are used for multiple activities, we can transfer this trouble for drinking water treatment. And then we start to have a public health trouble, or even to recreational or professional activities by other routes. So we know enough of that we could be exposure by different routes for cyanotoxins and cyanobacteria too. The next one. Considering the most known case about short effects in humans, I need to point out that short effects have been already enough studied, but we need to improve the chronic effects, long-term exposition, subchronic exposition. We know enough about the toxicology, acute toxicology of cyanotoxins, but we need to know more about the long-term subchronic exposition about this. So we have enough data about these short-term effects in humans. Usually we have gastrointestinal illness already registered, for example, in Argentina, Brazil, where some populations, sometimes a huge amount of people could be affected. And maybe in one scenario, we have a bloom. This bloom naturally can break down, but when it occurs naturally, all cells doesn't die in the same time. We are doing a slowly degradation of this bloom, and the toxin starts to be released slowly to the water. But if we do some managed action, because people doesn't want to see a green water, and they want to kill cyanobacteria, but they forget that. And I kill cyanobacteria using, for example, a chemical treatment. I broke this, and the cells lyses release these toxins to the water. So I start to have dissolved toxins, and no more intracellular toxins. Our water treatment systems, usually they are enough to remove cells, alive cells, so we can keep the cells and the toxin inside. But when you broke cells and the toxins could be released, the water treatment usually is not effective to remove the cyanotoxins. So a scenario that can promote some gastrointestinal illness for the population that receives this water, okay? So we need to be alert, and we need to consider it even during our treatment system. Some people want pre-pollination. I understand why they need to do it. They need to be aware that when they do pre-pollination, they worse the problem because they will have the dissolved cyanotoxins in water. Okay? Next one. But unfortunately, the worst intoxication of human beings not occur by roots. It occurred in the beginning of 1996 in a town in Northeast area in Brazil named Caruaru, where around 100 renal patients that needs to receive hemodialysis start to present a liver failure with symptoms so related with microcystin intoxication. That time, the symptoms from hand that we used to do bioassay, but the profiles of laboratory profile, histopathological analysis, clinical symptoms are completely related with microcystin intoxication. After some histopathological analysis and also chemical analysis from the liver, from patients that died, and blood sample from that one that stay alive, we can prove that could be justified by the amount of microcystin we found in that patient. So, until October of 1996, 6 people died by this intravenous intoxication due to microcystin exposure. The water was not enough treated. It's a sad story, a long way. Unfortunately, we don't have to talk more about this sad story today. But even it's so sad, there's some positive consequence for this. Next slide, please. So after that, in 1998, WHO finally decided to publish a book, a guideline about cyanobacteria in water. This book changed to be a Bible for anyone that works in fields, since engineering, management, biologists, and so on. Until now, it's a Bible, and I hope until the end of this year, the second version and the revision version will be published. Also in Brazil in 2000, we did a review about our legislation for drinking water quality, and in a pioneer decision, the monitoring program in the raw water for cyanobacteria in drinking water supplies started to be mandatory. Nowadays, in that time, there is an obligation to know how much cyanobacteria in the water bodies used for drinking water supplies. And we establish a TDI value, the maximum valuable acceptable for cyanotoxins concentration in potable water. So we thought about that experience, and we are trying to improve each year the control and management of this problem in our water supplies. Of course, it's much easier to do legislation than to apply the legislation. So it's a long way to transform it in a real better scenario. Next, please.
Professor Azevedo, 5 minutes left, please.
Oh, I'm leaving. Okay, let's run. Okay, nowadays we know that exposure to cyanotoxins can happen by different routes. Oral exposure, as I have already talked, water, food that can be accumulated this toxin, even recreational activity. Inhalation needs to be considered even for recreational or professional activity done in this environment that present bacterial blooms, and intravenous now. because we to think about the water quality for hemodialysis treatment for renal patients and parental support for those kids that are hospitalized. Next. This table that I am presenting here, just to prove you that there is a huge amount of data, much more days about the accumulation of toxins in some common fish that we regularly for our meals. Tilapia is a common fish in Brazil. This paper was done by a group working with Jacarepaguá, tilapia, and the TDI, the maximum amount of microcystin found in this fish is very higher than the maximum acceptable level. Next. Okay, let's move to look at about the amount of knowledge we have generated in Latin America. Look at this overview for more than 70 years ago, we can realize that these issues still to stimulate people to work on. These issues, even general issues on cyanobacteria or cyanobacteria and cyanobacteria, we still have a number of publications. And in Latin America, the number of publishing papers, in my opinion, are dependent of academic activity in the countries. When you have a big team work on it, well, of course, we have more knowledge or more publishing paper on it. Next. Okay, but when you compare the number of publications with bio publication, we can realize that we are around 10%. Okay, it's good because when you consider the size of our population and the size of our territory, it's okay. And the number of publishing papers are increasing. We are doing a good job. Next. So, what do we know in Latin America about ecophysiology of cyanobacteria? We know which are the main you know well, and the main environmental factors that control the cyanobacteria growth. We know enough about it. Okay? Next. The most common genera of cyanobacteria in our countries are Rhapidiops, the old Cylindrospermops, Dolichosperm, the old Anathina, and Cis, the colonial one. However, it is the main common genera. Okay, but we have some gaps that we need to face. Okay, for example, for identification and classification of cyanobacteria, usually it's the most common data we found in developing countries. But sometimes we need to harmonize this data that usually are restricted to academic institutions and release this information to decision makers. We need to improve the communication and put this data in a way that is easier to be used for those that need to do some decision, mainly during a crisis period. We have much more literature available about the morphotypes from temperate regions and less literature about morphotypes from tropical regions. So we need to improve our knowledge about our strains, our morphotypes, and to reduce laboratory program analysis for phytoplankton, we needed to use more genetic probes. We needed to face molecular biology to improve the necessity to have faster and good information that people needs to decide, okay, I can use or I cannot use this word now. They cannot wait 2 months to have a result. Okay, next. In ecology, we need to study more the dynamic of toxin production in different environmental conditions. For example, why we have stronger toxicity production in the beginning of a bloom and not the end of the bloom. Why the specific anthropogenic activity interfere some species of cyanobacteria, for example, pesticides, pharmaceutical compounds. But in general, we have information about ecology of cyanobacteria. Next. So, consider the main managed actions already established in Latin American countries. We can say the phytoplankton monitoring is the most common one. Everyone are doing, even it's not enough level. Sewage treatment plants need to be implemented in a national level. Some regions, some cities have good sewage treatment plants, but the majority we don't have. Also, drink water guidelines need to consider cyanobacteria, sometimes in regional level, sometimes in national level, but we need to forward these issues. Improvement of drink water treatment, we need to improve it for everyone. And we need to be aware about other kind of exposition, for example, recreational activities. Uruguay is doing the best example I know about it. We need to learn with them how we can improve it in our countries. Next. So, in my opinion, the main problem for Latin American monitoring program is the frequency of historical records. We are not adapted. We don't have history yet. We have sometimes records, sometimes someplace, and we need to harmonize our data much better. We need to improve local knowledge. We need people that can recognize faster and precisely. Okay, we need to stimulate different techniques level to recognize the problem, to design a early warning system for control this problem. Of course, it's a high cost in anywhere, so we need to optimize the sampling strategy. But to optimize sampling strategy, we need to have history records to know which period I need to identify the sampling of in the environment. And optimization of communication among different authorities. We need to talk with each other. The movement of environmental people, water quality, and public health need to be harmonized. We need to talk, we need to match each other, to design a threshold, we design an actual program for monitoring that work well in a crisis moment and putting a long term, okay? Next. Okay. In chemical and ecotoxicology, we need to improve the facilities and expertise that we have for analytical techniques. The problem is sometimes we have the facility and we don't have expertise people. Sometimes we have expertise people, but machines to operate. Sometimes we don't have nothing because we don't have money. But we can develop alternative toxicity tests. We are able to do it. We need to face our social, our reality, and I am sure we have enough knowledge to develop alternative toxicity tests. And of course, the standardization of analytical techniques. We need to compare our data. Okay, next. Okay, after several days our studies about cyanotoxins, we know we are talking about potent toxins. Some of them are possible carcinogenic, for example, microcystin. They can occur any aquatic environmental, but much more by an intracellular view. The high amounts stay inside the cell. They are so deep molecules and chemical structure that means different analytical techniques to be analyzed, and they are considered natural products. So sometimes beyond the legislation, people doesn't look that natural things can be problem. Usually they consider good things, but they are not good things, okay? And we are facing a so resistant molecule, so persistent molecule, not easy to degrade. You need to know more how stable it can stay in water column, even when the blue is not there anymore, okay? Next. Summarizing our data, I'm finishing. Next, please. In general, consider information about our crops. We have good information about physiology, biochemistry, ecology, ecotoxicology of the most common genera of cyanobacteria. We have very good information about this biology of cyanobacteria. Also, we have good information, enough information about environmental conditions that promote the dominance of cyanobacteria. We know enough about this. And we also have technical reports, books to know us, to teaching us how to manage and how to control the most common genera of cyanobacteria. There is no new way facing academic challenges. Of course, we can explain, we can study much more, but to solve the problem, we have enough tools. What's missing then? Next, please. Translation of knowledge. We need to listen and talk much more with different actors. Needs to be related to solve this problem. We need to talk with engineers, we need to talk with chemists, to talk with biologists, we need to talk with decision makers for different levels, environmental, health, public health authorities, medical doctors, media. We need to sit around our long and talk about listen the limitation for different areas. Only way we can actually solve or the minimum to manage well this. That's terrible for everyone. We need to control better the eutrophication process and the cyanobacterial process, give better life for our people. Well, of course, we need political will. Without this, we cannot do anything. The next one, last one, I promise. Okay, environment and health are completely connected, but need to face as a multidisciplinary issue, and not in academic, as one academic challenge. We cannot postpone this challenge anymore, and I hope I can stimulate you to continue in this field. It's so important that young generation interested in this. Thanks so much for your attention. Gracias por su atención.
Professor Sandra Azevedo, we highly appreciate your important keynote address. Thank you very much. Now it's time to open the forum for questions and comments from our attendees. We still have time for one question, so I'm going to read it for you so that you can provide the answer you consider. The question is, what in proportion are playing greater role in cyanobacterial increase? Wastewaters from domestic uses or from agricultural uses or from industry at all sorts?
Sorry, but I don't have a clear answer for this question. It needs to be analyzed in a watershed. In some regions, for example, the agricultural activity, we say agro-industry activity, is responsible for a huge amount of nutrients that comes from rivers and dams for reservoirs. But around metropolitan area, for example, close to São Paulo city or Rio de Janeiro city, our biggest cities, it represents much more from wastewater not well treated or without any treatment. So there is no general answer. We need to know we need to know better which the main impact of that environment. But it's not so difficult. Usually these data are right there. We can analyze it, and cyanobacteria will respond differently or similarly in different regions. It's not possible to say, okay, wastewater is more important. Depends the amount of things and the turbidity that you provoke the water and how you are changing the water to allow a dominance of cyanobacteria. I don't know if it's enough.
Yes, unfortunately, time is running out.
Okay.
Really fast, and we must close the session. On behalf of the organizing committee, I want to show our appreciation to our keynote speaker, Professor Sandra Azevedo, for her contribution to the pre-conference virtual event of the 18th World Lake Conference. We will continue the discussion. For those who already asked other questions, we will continue the discussion of this important topic during the following panel. Thank you, Professor, for your contribution, and we will continue with the program.
Thank you so much.
Thank you. Well, according to our program, we now proceed to a presentation about the International Lake Environmental Committee Foundation by Dr. Walter Rast.
Yes, thank you, and hello again. I didn't realize I would be on stage again so quickly. I would like to show you just a few brief things about the International Lake Environment Committee. We call it ILEC, and I've been associated as Dr. Azevedo and Alejandro Juárez, who will be the moderator of the next session for a number of years. And what is ILEC? Well, I'll show you now. Let me go back to this. Okay, what is ILEC? It is, formally it's called this Public Interest Incorporated Foundation. It's actually probably the world's foremost non-governmental organization, as opposed to public. I mean, it's there, but because it's physically located in Japan, it has to follow Japanese rules about taxation, all that sort of stuff. It is located in Japan on the headquarters, the secretariat on the shores of Lake Biwa, an ancient lake, the largest one in Japan. Its mission, its overall mission in one sentence, is to promote the rational and sound management of lakes and their catchment areas consistent with sustainable development goals. And sustainability is important because we're talking about sustainable, ultimately, ecosystem services, what they do for us. Okay, next. It was formed actually because of a conference that was in the Shiga Prefecture in Japan again in 1984. The first nationally or international conference that focused specifically on lakes. Next slide. You've gone back to the first one here. Nope, the other way. Okay. And it was formed because the then executive director of UNEP, United Nations Environment Program, liked it so much that he wanted the work, discussion of lakes to go on beyond the conference, not just a one-time event. And that led to the formation of what's called the ILEC Foundation in 1986, and he said here, I just put his quote here, I'm therefore proposing that we establish an international Shiga committee to follow up on the work of the conference. In this way, we would sustain the spirit of Shiga and draw public attention to the plight of lakes and their nurturing river systems. And that's the basis of which it all formed. And the Shiga Prefecture took up and when thanks to them, took up the goal and established a foundation, and then ILEC existed, but it is an independent foundation, totally based on its own work in the scientific committee. Next. And vision, lakes are vital water resources, and they support a wide range of life-supporting ecosystems, many are in critical condition. Because this is kind of important, because if you look on a global map, you see the Earth, it looks blue, which means we have a lot of water. But you then stand back and say, well, 3/4 of this is too salty for use. Nearly all the rest is in glaciers, at least on the surface, is in glaciers and icebergs and so forth. When you take a cold, hard look at the surface of the world, approximately 1%, believe it or not, the statistic always surprises me, is in liquid freshwater farm on the surface of our planet. And of that 1%, more than 90% of it happens to be in lakes, man-made and natural wetlands, and other standing water systems. And so those are the ones we have to focus on, which is why one of the reasons ILEC exists. And it promotes integrated management and their sustainable use. Collaborates with the governments, with UN organizations, with the private sector, and so forth, to conserve lakes and other inland water systems. Some of the little examples there are on the bottom of some of the problems that we have been working with. Next. Just a quick thing to show you that everybody has to have a structure. We're more interested in the board of directors and the scientific committee there, and the secretariat, which is on the shores of Lake Biwa. The president of ILEC is of the upper right corner, and then the lower right is a fellow many of you who know his ugly face. That's Dr. Nakamura, a good friend and colleague, and he has been instrumental in promoting the use of integrated lake basin management, which is one of the major focuses of ILEC. Next. Oh, and then we have our scientific committee. And you may note on here, in addition to my fat face on the upper right side, we have Dr. Azevedo is one of our scientific committee members, as is Alejandro Juárez. And these people are recognized scientists in their own right, and they're on all the continents, and they provide the scientific direction in the policy statements for ILEC. Next. What does ILEC do? They do three main things. They promote lake basin management on a global scale, projects in many places, dealing with lake basin management primarily, not engineering projects per se. They support local host organizations, in this case, University of Guanajuato, for World Lake Conferences. We're now going to have the 18th, even though COVID-19 has pushed it back a little, we're still going to have it, and we will continue. And build capacity of stakeholders for lasting lake basin governance. An appreciation, we're talking about lake basin governance, in part because you can't manage a lake per se, except maybe for shoreline encroachment and building and fisheries. Otherwise, you have to manage what's going on in the lake basin, and how people are using the water and misusing it. That's one of the reasons that ILEC has such an extensive training and education courses. And you see the word JICA, that's the Japanese International Cooperation Agency. They sponsor training courses of all kinds for people from all over the world, and they have had a lot of graduates that have gone back to their countries and assumed reasonable positions and are able to push the lake agenda forward. Next. And here are the World Lake Conferences. Just, you don't have to worry about the words here, but you notice that the one for Guanajuato is now November 2021. It hasn't disappeared, as I said. We're just going to have it a little bit later. And these dots here show you where we've had previous World Lake Conferences on a global scale, because ILEC is, in fact, the International Lake Environment Committee, even though it happens to be physically headquartered in Japan. Next. And what does ILEC do? Well, I'll just go very quickly through these. They maintain a World Lake database. You can go on it and find information about many lakes. They have prepared a whole series of lake management guidelines. You'll see 9 booklets there. And they've developed the World Lake Vision. This came about because many of you may or may not remember that the World Water Vision was put forth probably several decades ago now, and we were concerned that it didn't really address the unique features of lakes and how they have to be assessed and managed somewhat differently than say, flowing rivers or groundwater. And so they developed the World Lake Vision that provides principles, general principles for managing lakes per se. Next. And then we get hot and heavy because we had a Lake Basin Management Initiative. This was basically the birthplace of ILBM. And I always thought it funny that it's LBMI and it's the parent of ILBM, which is the next thing that came across below. The Integrated Lake Basin Management Platform, we call it. It was launched at the 11th World Lake Conference in Kenya and has been a major activity of ILEC ever since. ILEC has also been involved with some work in Africa. I just highlighted it's not the only place. We've been involved with governments in Nepal and India and Indonesia and Malaysia and Kenya and Ethiopia and Japan and China and quite a few projects. We work directly with many government agencies as opposed to projects per se. We've also been involved with in a GEF project, the Global Environment Facility. We do what they call the Transboundary Waters Assessment Program. It was undertaken by UNEP. It's supposed to rank water bodies, lakes, rivers, groundwater, large marine ecosystems, or coastal waters, if you want to call them that, and the open oceans, as to how they are threatened, because the GEF receives many project proposals wanting funds, and the GEF literally needed to know which one is more important, which one is less important, which one should we focus on first. Next. And we've put out these reports on how we have assessed transboundary lakes around the world. One of our surprises was that even though you can see them on a map of the world, the drainage basins for many of them had never been delineated. So we had to spend a lot of time actually deciding how long or how wide the drainage basins were. And then we're continuing to promote work in Africa and elsewhere. I just happen to have photographs here from Africa. Next. And so what is ILBM? Yeah, I got just a couple more here. I just put the word down here, the things in quoted. It's an approach for achieving sustainable management of lakes and reservoirs, as well as other standing bodies of water through some words I underlined here. Gradual, continuous, because it is not a one-time project. It's a process that will go on like forever. And holistic improvement of lake basin governance. And it then includes the 6 pillars of the so-called ILBM pagoda, meaning institutions, policies, this political will that Dr. Azevedo talked about, participation, stakeholders. If you leave them out, you're not necessarily going to have a good management plan or a successful one. Knowledge, whether it happens to be scientific or you go to the old elders in a village, for example. They've watched the lake for 50 years. They know what it was like then and now, and it may be the only data sources you have. And finally, funding possibilities. Unfortunately, everything seems to cost money, and so we need sustainable and adequate funding for successful management of the lake and its basin and its ecosystem services. Next. Okay, and I just want this one here. I just mainly show you the map, which shows projects. I call them projects. They're not really projects. They're processes, governance processes we have going in all around the world. And at the bottom, you see some of the plans that have come out of these particular components. Next. And we have declarations, starting way back in '84. They have come out of a number of these that have guided work. And these are declarations put together by the host organizations in collaboration with its partners, not something that ILEC thought up. So it's the people that are using the lakes and governing them that are putting these together. Next. Okay, and then this last slide here just shows you some of the JICA, the publication, the people that have been trained. More than 1,000 attendees have been governed or received courses in assessment and management of lakes from 65 countries that have gone home, and hopefully they've been able to do a great deal once they've gotten home and have learned a great deal from ILBM, because we're continue to be in communication with most of them, and their help is very useful. Next, I think that's it. Okay, and that is it, and that's a very fast run. And by the way, all those reports that I've talked about integrated lake basin management and so forth, if you want, they're available on the ILEC website, and it's really quite easy, ILEC for ILEC.OR for organization, .jp for Japan. And you go on there and you're going to see all these reports are available. They're downloadable, and many of them are in Spanish and French and other languages. So feel free to go there, and you'll see a great deal more than we can tell you in a 2.5-hour webinar about lakes and and their appropriate management. And with that, I thank you for your attention, and I will return it to our host.
Thank you, Dr. Walter Rast. Thank you very much. Well, now it's time to make a projection of a promotional video of the 18th World Lake Conference. And then after that, we will continue with the panel. Please go ahead.
18th World Lake Conference, University of Guanajuato, Mexico. November 2021. Governance, resilience, and sustainability of lakes for a better society. Keynote speeches, conferences, technical sessions, poster presentations, student workshop, young researchers, and the Kasumigaura Prize Award Ceremony. The conference also includes several cultural activities as well as organized tours to visit the state of Guanajuato's most emblematic landmarks. For more information and registration to the event, visit www.worldlakeconference.ugto.mx. Hosted by University of Guanajuato, Guanajuato State Government, National Water Commission of Mexico, and the International Lake Environment Committee Foundation.
Now it's time to start our discussion panel. To do so, it is my pleasure to introduce Mr. Alejandro Juárez Aguilar from Institute Corazón de la Tierra in Mexico, who will serve as the moderator of our panel. Alejandro Juárez Aguilar is an expert in lake and basin management and has 20 years of experience and certification from the U.S. Forest Service, the Arizona Department of Wildlife, and the International Committee on Lake Environment. Focused mainly on Lake Chapala, he has coordinated 73 research, planning, environmental education, forest management, and community development projects, including the Ramsar Management Program of Lake Chapala. He has been an advisor and speaker in Mexico, Japan, India, Spain, Italy, and 10 other countries. He's the Director General of the Institute Corazón de la Tierra, member of the Scientific Committee of ILEC, and leader of the Lagos Working Group in the Mexican Network of Watershed Management. Please, Professor Alejandro Juárez, go ahead.
Thank you very much, Eric. It's very nice to be here. I am very glad to have the opportunity to coordinate this panel. Congratulations also to the World Lake Conference 18 organizing committee for making this pre-conference event possible. Basically, this panel will focus into broadening or going deeper into some of the issues that Dr. Azevedo mentioned in his previous presentation. And there will be a quartet of well-recognized lake and water management professionals taking part. I will welcome them now. So please activate your video, or wait, you have it already activated when you are mentioned. First, we have Claudia Nava from she's a biologist from the National Autonomous University of Mexico. She has a master's degree in biotechnology from this university. From 1995 to 2005, she worked in the private initiative developing basic engineering of projects related to sanitation. In 2006, she joined the National Water Commission, or CONAGUA, in Mexico as a project manager. And in 2019, she became submanager of water quality in this same institution. Claudia Nava, welcome.
Hi, thank you. I really appreciate to participate in this panel. Thank you very much for the opportunity.
We have Laura Benegas, an agricultural from the National University of Asunción in Paraguay. Master's in Integrated Watershed Management from the Tropical Agricultural Research and Higher Education Center, or CATIE, and she has also a PhD in Soil Sciences from the Swedish University of Agricultural Sciences. She currently coordinates CATIE's Resilient Watersheds, Water Security, and Soils Unit. And also she has coordinating the CATIE's Master Program. She's specialized in both academic and extension approaches and project implementation in areas such as watershed management and others. Welcome, Laura.
Thank you very much for this opportunity. I think my camera is, my video is giving some trouble. Hopefully it will work better later. Thank you very much for the opportunity to share experiences in this panel.
We hope that the video problems could be solved. If not possible, we have at least the opportunity to hear you, and we are sure that you will be presenting some very, very interesting points of view. Next, we have Eduardo Ríos. He is co-coordinator of the Mexican Watershed Network, or MEXCO, from 2011. He's member of the organizing and he has been member of the organizing and scientific committees of 3 national watershed congresses. He was head of the Environmental Policy and Planning Unit of the Secretary of the Environment in Mexico. He currently teaches public policies and environmental legislation at the National Autonomous University of Mexico. He has a bachelor and master's degree in management from Managua University, and he's currently working in a PhD program in public policies by the Institute of Economic and Business Research in the state of Michoacán. He is here, I think. Welcome, Eduardo.
Hello.
Hello.
Thank you very much. I am honored to be here with you and to share some experience and help with all of you.
Thank you for sharing, and thank you for being here. And last but not least, we have Walter Rast. He's a PhD degree in environmental science from the University of Texas at Dallas. He has been senior environmental advisor to the U.S.-Canada International Joint Commission from 1978 to 1986, then focusing in the North American Great Lakes. He also has been a research hydrologist with the U.S. Geological Survey, deputy director of the water branch of the United Nations Environmental Program from 1993 to 2000, and then he served as director of the Aquatic Resource Graduate Program at Texas State University until he retired in 2017. He is currently chair of the Scientific Committee of ILEC, and his professional activities focus on the integrated management and sustainability of natural and man-made lakes, wetlands, and other lentic water systems, their basins, ecosystem services, including scientific, socioeconomic, and governance implications. Walter, welcome again.
Come on, am I on?
We hear you.
Start video. Okay. I'm sorry. I'm sure everybody's probably tired of hearing me. And all those jobs you decided, or all those things you said I've done, I wonder if it just means that I can't keep a job in one place. Anyway, I'm glad to be here. I continue to learn stuff, and this continues to be my love, in addition to my wife. And I look forward to our discussion. Things like this that can form ideas that move forward. So, thank you for having me, and then let's go.
Thank you. So basically, before going on, I will explain some general rules so that we could be able to make good use of the time we have. Basically, we'll make rounds of questions, and these will be directed to all panelists, or only if other thing is commented. The time for individual presentations must be not higher than 3 minutes, so please be very respectful of the time of the other participants. 30 seconds before this time ends, I will send a message by chat mentioning that you are approaching to the end of your intervention. Please keep your microphones off when you are not speaking, and generally speaking, the issues that we are going to talk about will be the keynote and also related topics. So we're not going to talk only about cyanobacteria, but also about the situation that caused its appearance, like agricultural runoff, wastewater treatment, situation of climate change, and so on. You can use your time to comment about your specific lakes or basins, or if you want, you can talk about the general situation in countries, the Latin America region, or another region in the world. And we will have the opportunity to have 3, maybe 4 rounds. And in the final one, each panelist will have the opportunity to make a conclusion. It's 2 minutes for each one, summarizing the comment that you have, or maybe having the opportunity to make a reflection about this. You are free to use charts and figures as a backup if you like. And in that situation, the first round will start now. I invite first to Walter Rast, then I will ask Claudia Nava to come in, and then Eduardo Ríos, and to close, Claudia Benegas. So, Walter, if you like, please go ahead. And the first round, sorry, I was missing the point. You have now the opportunity to comment about the presentation that Sandra Azevedo make, or you can start with this question: how serious is the presence of cyanobacteria, another manifestation of excess nutrients like water lilies and cattails, so on, in the lakes that you are having working in? So please go ahead.
Well, I don't have a lake specifically, so I can generally just make the observation that cyanobacteria are, in my perspective, they are the most extreme, almost the most extreme form of eutrophication. And that's important because eutrophication is probably, well, it's not probably, it's the most pervasive water quality problem on a global scale. In ecology, eutrophication is literally the natural aging process of lakes. It can go on for generations, even in the absence of human beings, because it rains and water flows over the land surface and takes leaves and dirt and so forth, and that cannot eat a human being. And eventually those things will decay, or our nutrients are associated with the soils, and they will become slowly over geological time, it can become filled and shallow and then literally become land. It's the human activities in the drainage basin that accelerate this process, and we separate it from natural eutrophication, and we call it cultural eutrophication because it has anthropogenic sources. This is what we are continually fighting. We're trying to adjust because, like it or not, almost every human activity degrades the environment. And that would be okay, I suppose, if it stayed in the watershed, but unfortunately for us, it also rains. And things, even non-point source, as Sandra was talking about, wastewater treatment, 22% is properly treated in Latin America. That means 78% isn't. And so we have, in that case, a biologically available farm, which is more precedent. So that's why she was saying it's difficult to say. But we also have runoff. That's what they found in the North American Great Lakes, because Lake Erie was suffering anoxia and fish kills. And they looked at all the point sources, the sewage treatment plants, and realized the extent of eutrophication was greater than that could be accounted for by the sewage treatment plant discharges. That started a non-point source study in the entire Great Lakes Basin that is to this day the most comprehensive non-point source study that's ever been done. So non-point sources are important, point sources are important, eutrophication exists. It would exist whether or not we were there. It's just what we can do in the watersheds and even outside the watersheds, because we have long-range transport of airborne pollutants to address the problem. Because as your next question is going to say, do we treat the symptoms or do we treat the effects? And I think we have to, symptoms are the causes, and I think we have to focus on the causes. I didn't mean to ramble so much, but just eutrophication is a very big problem. Sandra's pointed out in Latin America, but I've been all over the world with UNEP, and trust me, it's never problem everywhere. And some of the stuff I might show you if I have time, a few pictures of eutrophication, the extent of algae that I can hardly believe it, except that I can see it. Okay, thank you. I'll stop there.
you very much. I think it's a very interesting approach because this problem is not only allocated in the Latin American region. So now we will have the opportunity to, it seems to be a problem with the internet here.
I can hear you.
Okay, I can see you too. So please, now we invite the specialists from the National Water Commission from Mexico, Dr. Nava, to come and make your comment, please.
Thank you for the information that I am a doctor. I'm not a doctor, only master. Thank you.
Okay. Sorry.
No, it's okay. I will share a presentation with you, a short presentation. In Mexico, excess nutrients are a major problem in lotic water bodies like rivers and canals, and lenticks such as lakes and reservoirs. Based on the results generated from 2012 by the Water Quality Measurement National Network of the CONAGUA, this Water National Commission, the map shown in the slide was obtained. In this map, the points indicated with triangles correspond to lentic water bodies, and the circles to lotic water bodies. Blue indicates oligotrophic conditions, orange indicates mesotrophic conditions, and yellow indicates eutrophic conditions. Based on the above, the majority of the water bodies are eutrophic. Then you see the problem in our country is very, very important. With regard to lentic water bodies, 300 more or less were monitored, of which 23% are oligotrophic, 30% are mesotrophic, and 39% are eutrophic. In the following slide, it's only an approach showing lentic water bodies. The percentages are the same as in the previous slide. Taking into account above, most water bodies in Mexico have problems with eutrophication, and therefore the presence of cyanobacteria or weeds associated with high nutrient concentration. Among the dams with the greatest problems associated with cyanobacteria or weeds growth are the Boca Dam in Nuevo León, the Cutzamala Dam system. This system is very, very important for Mexico, and mainly in Villa Victoria and Valle de Bravo dams. These dams supply drinking water to the Valley of Mexico, and Yosocuta Dam in Oaxaca that supplies water to the city of Guajuapan de León. Therefore, are also records of cyanobacteria in the lakes of Sirawen at Pátzcuaro, Michoacán. Even in one occasion, there was the presence of a strong growth of anabaena in Lake Chapala, one of the main lakes in Mexico. With this information, I finish my participation.
Thank you very much. That was quite illustrative. The situation doesn't look easy now at this moment in Mexico. So now we will change to another country, and we will invite our participant, Laura Benegas from CATIE, to share your comments with us, please.
Thank you very much. Can you confirm that you can hear me? Yes, I just want to check if you can hear me. Sorry?
I can hear you.
Yes, because I still have some problems with my internet bandwidth. I would like to talk about two examples, two interesting situations that we have in Central America and also a case in South America. So the watershed of the Lake Atitlan in Guatemala is an interesting case because we have a type of deep water with a median or average depth of 200 meters and the maximum reaching between 300 and 400 meters. We have a watershed of the size of 500 square kilometers, and the lake surface is around 123 square kilometers. We have there around 85,000 inhabitants, and of course the touristic activities is really important. Atitlan is known as one of the most beautiful lakes in Central America. And we can compare this with the opposite situation that we have in South America, actually in Paraguay, this is the lake Ipacaraí, which is the opposite because it's a shallow type of lake. We have just an average depth of 2.5 meters and a maximum of 4 meters. The size of the watershed is twice the size of the watershed of Atitlan, and the size of the lake is half the size of Atitlan. But they are different in terms of structure, but similar in terms of the problems or impacts of eutrophication and cyanobacteria blooms, because touristic activities are the main livelihood for people living in the surroundings of these lakes. We have 15 municipalities in the shore of Atitlan Lake and 21 in Ipacaraí Lake. And when we have this high level of blooms in cyanobacteria back in 2009 in Guatemala, the touristic activities and livelihood was severely affected, and also health damage from toxins and increases disease prevalence from these blooms. And in Ipacaraí, there is also a history of up and downs in terms of eutrophication. And of course, we have a situation a little bit different in terms of the causes of these blooms or these processes of eutrophication. In the Atitlan Lake, we have as a main cause actually the agricultural activities, loading high levels of nutrients coming from fertilizers and also for erosion and sediment loads into the lake. And this is always the understanding, or it is more famous to a point that the cause is the wastewater coming into the lake, given that domestic waters are not very well treated. But the situation is not actually that way. We have 67% of nutrient loads coming from erosion, and just 16% of wastewater coming from domestic points. And in Ipacaraí, we have a different situation. We have 21 municipalities surrounding the lake. And for there, yes, we have 80% of the nutrient input into the lake coming for sewage, like wastewater, and also a 20% nutrient load coming from industrial uses, specifically slaughterhouse facilities. This is quite common in this area. So causes means that we have to think about the integral solutions. That means that we have to think in the several alternatives to deal with this, and the more famous in both cases, what is the commitment for the authorities, and like the most interested issue or situation to be tackled is the sewage treatment, the treatment plants that needs to be worked more properly. Because, for example, in Atitlan, from the total of wastewater from domestic waters, we have just 28% that are treated at some level with not all the regulations are complied by the different municipalities. But in Ipacaraí, we have a situation more complicated because just 2 municipalities up to the 21 that we have there are treating in some level of technologies the wastewater. So there is a lot of work to do there, and the idea is to work with a network of wastewater treatment plants there, and it is more or less or relatively easier to do because there is no installation yet in all these municipalities. So this is interesting to consider, and also to consider the other causes that are less attended, which is the ones related with agricultural activities, and that's the challenge. So I will stop there, just introducing the problems and situations there into interesting lakes, to interesting and contrasting cases, but also with some similarities in Latin America.
Thank you very much, Laura. In fact, I think that the Atitlan Lake in Guatemala is a very, very interesting and important case. because there have been not only cyanobacteria bloom, but also problems with other kind of floating plants. And it has generated a lot of social responses, some of them quite interesting.
Yes, I hope that I can mention the solutions later. Yes.
Yeah, exactly. I was about to mention that it would be interesting if you could continue about this aspect, particularly with the Atitlán Lake and the part of how it has been dealing with. Thank you very much. And we will go back to Mexico again, and we will ask Eduardo Ríos from the REMEXCU, the Mexican Watershed Network, to share information with us. Go ahead, Eduardo, please.
Okay, do you listen to me?
It's loading, I think. It's a black screen. Okay, now there it is. Eduardo, you have your mic off. Okay, these technical situations tend to be messy sometimes, but anyhow, we have the opportunity. We heard 3 interesting comments, and before moving to the next question, we have a particular question from one of the participants related to the situation in Mexico. He is Alejandro Juárez, and he asked if it would be possible to share some examples about how Mexico is taking advantage of big data management and technologies to measure the real impacts of these water bodies on the country, and if it's easy possible to have better and more robust information to deal with this problem of cyanobacteria and eutrophication in general. So would you be so kind, Claudia, to make a comment about this?
Yes, how I told you, this information is the basis to make another actions. This information is given to another areas of CONAGUA. These areas is like wastewater treatment plants and drinking water plants, and these areas apply or use this information to make infrastructure, new infrastructure to avoid these kind of problems. In a moment, I will talk about a successful case. This is in Cutzamala, and you can see what we can do when we have these kinds of problems. I don't know if I answer your question.
Oh, I think that the question is quite wide. We will need like a couple of days to go deeper into that, but I think that at this moment it's quite precise, the comment that you made. And I don't know if Eduardo is back with us, or we should move to the next question. I think so. And then we can go back later with his participation. There is something interesting that happens all over the world, is about this problem. First, as Sandra Azevedo mentioned, sometimes it's difficult to recognize or to accept by political.
Do you listen?
Hello?
Do you listen?
Now? Yes.
Do you listen?
We can hear you, yeah.
Okay, now you listen to me? So yeah. You told me if I speak this round or to the next one.
Oh, if you are back, please go ahead. Are you going to share the screen?
Yes, I will, if they give me permissions, please.
Okay.
Okay, so very fast, I'm sorry about these technical situations. No? I wanted only to thanks to ILEC and to University of Guanajuato the opportunity of participation in this panel. So as Claudia Nava expressed the seriousness in those incredible maps, that I haven't seen those maps, and I invite Claudia Nava to our working group. So the degree of impact and the seriousness of eutrophication, as she showed us in Mexico, emerged due to the intensification of problems associated with social demand, range from economic impacts due to the limit of recreational activities due to algal blooms, or the extension of lily pads and aquatic vegetation or invasive species that have serious problems in fishing, to problems that affect biodiversity by changing the trophic dynamics and the conditions of the habitats of sensitive species, and their change to the most sensitive health problems due to ingestion or contact with toxins generated by this organism. So as Claudia, as authority of CONAGUA, told us, the systematic degradation of lake systems and their interconnection with the loss of connectivity of river systems, as well as the increase in human activities that accelerate the eutrophication processes of lakes and reservoirs, is verified in different degrees in the north, in the center, and in the south of Mexico. Well, as you can see in this map, the most quantities of lakes in Mexico and of dams and reservoirs are in the center of the country. And also, there is the most important pressures are there. So examples like Lake Chapala, with eutrophication as a consequence of the decrease in the inflow and pollution, as well as the loss of volume due to the extraction and the excess of nutrients, or Valle de Bravo Reservoir, that provides water supply to the Mexico City metropolitan area, that increased almost 300% of phosphorus and 200% for nitrogen in no more than 10 years due to control domestic and agricultural inputs. Or urban lakes in Mexico City, like Xochimilco and the old lake of Chapultepec or Tesosomo Lake, or in Michoacán, the lakes of Cuitzeo, or specifically Pátzcuaro and Siragüen, among only some of them. So yes, the problem is serious, and I think it is a contextual opportunity to work hard in this working lake group that has been formed now with more and more people involved in this activity. Okay, so that was my answer.
Thank you very much for Eduardo. Okay, now I think it's time to have a complementary question for you. The four of you mentioned some of the strong effects that eutrophication is having, cyanobacteria including as one of them. But about that, the kind of measures that have been taken in your respective countries or region, basically, are they focusing on the effects? I mean, extracting aquatic vegetation, extracting dead fish, so on? Or do they address the causes of the same? And in such cases, what's the level of effectiveness that you are having or you are looking at it? Again, I will go back with Walter, if you could make a comment on this. The order of intervention will be the same. First we will have Walter, then we will have Claudia Nava, then we will have Eduardo, Benegas, and finally Eduardo. So, Walter, go ahead.
Okay, thank you, Alejandro. Can you hear me okay? Okay, good. I can't tell. And we're all getting used to this new electronic stuff, and it's driving all of us crazy, as you can see. Listen, it's difficult to provide a general answer to that question because it depends much on how big a watershed is, how many people are there, what the water uses are for, and the degree of development of a country. For example, I mean, in my area, if I stand back and look, water as a resource is under the jurisdiction of each state in the United States. The EPA can provide water quality guidelines that the states are supposed to make, but the federal government doesn't control water. The states do. So, and obviously, each state has its own. We have the Texas Commission on Water Quality, and each state has their own version, and depends on how important the water is within the context of that particular state. But I think it would be proper to say, certainly in the United States, that most of the effort is directed toward treating the causes, not the symptoms, because you can appreciate you can In fact, this afternoon, they're going to talk about the use of one of the products of eutrophication, which would be treating its symptoms, so to speak. Basically extracting it from water. I'm sorry, I'm not being very clear. But it's going to depend, if you look on a global scale, what is available in the country, what is the state of the development. As Sandra said, we need political will, we need money. That's not all. We need stakeholder participation, and we need institutions to carry out policy and enforce it, and we also need the best of knowledge that we can get. So these are all the pillars of the ILBM pagoda. But some countries aren't wealthy enough, so they can't put in sewage treatment plants or dams. They cost a lot of money. Other countries, they might have, they don't have money, but they might have a lot of labor that's relatively cheap, so they can go ahead and do things that require a lot of people, but not so much money. So that's why I say it's difficult to make a general statement about the globe. You might be able to put a particular region down, or even down in the U.S. to state level. But it all depends on how much money, how much political will, what the water uses are for, and so on. And I don't know too many places, although I do know some, Lake Victoria, they were taking out the water hyacinth, for example, as opposed to trying direct focus on treating the sources, which is activities in the watershed. So, I mean, I better stop now because I'll go on and on and on. So it's a difficult question to answer with a general answer, other than depends on the magnitude of the problem in any given area and how it affects the water uses and the people that use it. And then, of course, the will of the government. Are they interested in, are they pressured or interested or whatever in ensuring that the water is of good quality, i.e., so they take care of the pollution impacts, which is eutrophication. Okay, let me stop there so we can go on to others.
It seems that you hit some points there. In the case, it's difficult to talk in general way. Definitely, it's easier to understand or provide information when you are talking about a particular water body. So I think that will be interesting to listen now, Claudia, Nava, in the case of Mexico. What do you think about this aspect? Are the measures have been taken effective or not? And if that's the case, what would you think could be done? Claudia, please go ahead.
Thank you. In the Mexico case, efforts are concentrated on both causes and effects. In the other words, actions that are carried out related to the extraction of aquatic vegetation and causes are attended, mainly through the current regulation, establishing the maximum permissible limits for discharges of wastewater into the water bodies, due to its for the high nutrient content. They favor the process of eutrophication and therefore the growth of cyanobacteria. Mexico, the main regulation is called NOM 001. This rule establishes the maximum permissible limits of pollutants in water discharges into national waters and goods, which is currently, this law is currently in the process of updating. What is the goal? The goal is establishing stricter limits in nutrients and other parameters with the aim of improving the condition of water bodies. However, this action will not be enough. Actions must go further, such as reducing the amount of phosphorus in detergents, controlling diffuse pollution, especially the indiscriminate use of fertilizer use, deforestation, land use change, etc. On the other hand, we have another legal tool called special discharge condition. This tool applies to companies that discharge high concentration of specific contaminants, which must be regulated in a particular way. And I think this is my participation. With this, I finish.
Thank you very much. Going back to the map that you show in your previous participation, I think that would be quite interesting to look at this map, but over a time lapse. I mean, to see how the state of water bodies in Mexico has been changing from, I don't know, 5 to 10 years, something like that, in order to have a better idea how the process is moving and obviously related to the causes it generates it. And thank you very much, Claudia. Now I would like to invite Laura. I hope that we could see you, but if now please go ahead. And in your case, I don't know, you can mention about the situation in Central America, if you like, or you can continue with the situation of the Lake Atitlan. Please.
Yes, still not working my video. It's a problem of internet bandwidth, unfortunately. But I prefer to continue talking about the case of Atitlan, and this is because last year we cooperated in the formulation of the integrated watershed management plan in Atitlan. So the problems and the situations is quite recent and understood, very well understood for me now. So what I want to mention is that the solutions are based also in the symptoms and in the consequences, mainly. The other type of solutions attacking the causes are also part of the strategy, specifically what we propose in the integrated plan. But what we have is treatment plans working in a non-efficient way, because they are mostly designed to remove organic matter, but not to remove phosphorus or nitrogen. In the case that they have the design to remove phosphorus, like in Panajachel, which is the biggest touristic city in Atitlan, sometimes there is a problem with the just operation of the plant, of the installations. Sometimes there is no capacity for the operator in order to use, for example, the aluminum sulfate to precipitate the phosphorus. I mean, the technical capacity sometimes is lacking, and that makes inefficient part of these solutions. And also, I have to mention that similar to Mexico, in Guatemala, after the problems of cyanobacteria blooms, in 2011, there was a regulation, an agreement from a governmental agreement specifically for the Atitlan watershed. And from there, there is a mandatory kind of solution coming from the government that all the municipalities in the shore of the lake should improve or should build the wastewater treatment plants. And there are some of them, actually 12 of these plants that were built before this regulation, and of course they do not comply with the requisite, with the permission limits and this kind of things. So this is one part. There is another side of the population that are proposing, it's not yet implemented, but I have to mention the story of the mega collector, which is a solution that is aiming to extract and export the wastewater within the lake and try to move this into the coast for the treatment of these highly rich in nutrients water and to be used for agricultural purposes. So this is an idea of circular economy to produce a sustainable sort of options, like in the path to the coast, for example, generating hydroelectricity, selling the wastewater, the highly nutrient wastewater, as I mentioned. But this is a kind of controversial solution and has a lot of opposition, and it still needs to be better understood and studied. But an alternative solution that we can mention also that is promoted by some NGOs, that is to reduce the presence of cyanobacteria through the planting of a natural filter, which is a tool. This aquatic vegetation work as fixing the nutrients from pollutants outside the lake, is also attacking the consequence, and also take advantage of cyanobacteria blooms for the nutrients of their own development. This is also interesting for sort of cultural practices, because this plant is used in local sacred celebrations, for example, and this is also an endemic vegetation in Atitlan. There is also a side of population that is like proposing individual solutions. There is these local organizations that we have there, like the rural and community councils. One of them is proposing that every hotel And every installation has their own biodigesters. And just last solution is related with awareness and education of the population. So this is the set of technologies and solutions proposed for Atitlan. Thank you.
Thank you very much. It seems that you have a lot of insight about what's going on in Atitlan Lake. I think that's quite interesting and very useful, in fact, in order to guide the decision-making process. Now, to conclude this round, I will invite Eduardo. Please, in the case of the REMEX pool, because it's a network, I think it's quite interesting information that you could share on this. Please go ahead.
Do you listen to me?
Yeah, you do.
Okay, thank you. I hope my intervention is less chaotic, but as Walter says, we are all learning with this virtual scenario. So let's remember our question. Our question was that if we focus, that the measures we focus on effects or on causes, and what is the level of effectiveness. So I believe that the problem of eutrophication of lakes and reservoirs and its associated problems has had a differentiated attention in Mexico in terms of attention to causes or effects. From an empirical perspective, I can affirm that this differentiated attention depends, in general terms, on the degree of intensity of the problem and the speed of response to attend a social environmental problem that demands public intervention in the short term, and the existence of appropriate technology to focus effectively in the effects. In this way, institutional response to invest, for example, in lily extraction, or the use of technology to accelerate oxygenation or capture phosphates, processes in bodies of water focus on the effects. Actually, I consider that intervention strategies should include attention to immediate effects, but in parallel, public policies should be comprehensively formed considering the integrity of the basin as a functional unit. A solid scientific basis must be included, linked with the institutional level of the municipal, state, and federal level, and a broad participatory base focus on causes. However, these processes are very complex, multi-causal, and subject to great uncertainty, as well as the effects. They are usually long-term. In Mexico, attention to effects dominates due to the reactive nature of the institutional responses to problems associated with eutrophication, and to a greater extent, when the effects on the population are clearly visualized by demanding intervention from the authorities. So the effectiveness will depend, as Walter says, depends on the type of a strategy, depends on the situation, on the lake, on the reservoir. We propose the long but sustainable path in time of considering the problem due to root causes, from the specific identification of the impacts and the design of the instruments, from the knowledge of the structure and operation of the basin, and fostering broad participation. On the other hand, we also consider that intervention focus on effects, but from a prevention perspective, and even care for human health and the economy is relevant as well. So I think we need to build better strategies, finding the solutions of our reservoirs and watershed lakes. So this is a chart that I try to express what I have just told you, which is the short and the long term and medium term. There are all effect and causes and public policy intervention, but both of them must be implemented depending on the case.
Quite interesting, Eduardo. Thank you very much. Because of matter of time, the problem with panels is that there is many information to share, and unfortunately, we don't have that much time. But now we are basically entering the final part of the panel. So I will try to assign some particular questions that participants are sharing by the chat. And I will ask each one of you some of these questions because taking into account the previous information that you shared. So this is an interesting question. I think Walter will be interesting to answer this one. It's made by Felipe Valderrama from Colombia. He asked if circular economy models are the future of water, and more precisely, if wastewater management in lake basins located in developing countries. About this, I would like to share that 2 weeks ago, I had the opportunity to participate in a discussion, very interesting discussion, which was named Wastewater from Problem to Resource, with the idea of shifting the approach so that water could be understood like something that could be used somehow. So I think that probably the question that Felipe is making goes in that direction. So please, Walter, come on.
Okay, again, forgive me, the question sounded a little confusing to me. Was it, can you hear me, by the way? I never know if I'm on or not.
Okay. He's asking if circular economy models are the future of water, more specifically for wastewater treatment.
Oh, I see. So it's basically, can we use, I mean, it's another way I see the question, can we use the impacts of eutrophication in a positive way rather than it all being negative? And does that translate into economic impacts? And I would say yes. In fact, if you're able, this evening's presentation, which starts at 7 o'clock in the evening in Mexico, so we can actually see a 2 for the price of 1 today. The people on the other side of the world aren't seeing this seminar or webinar because they're all asleep now, but you'll be able to see both if you wish. But obviously, money and political will, as Sandra said, is at the base of a lot of this stuff. So yes, I'm certain economic models can help. The discussion this evening, as I understand it, is going to be how we use eutrophication. You'll call it impacts. In this case, macrophytes. Because when I was working with UNEP, I heard a range of possibilities. Macrophytes can be used as fertilizers. We can try and use them as livestock feed. And I was in India, and I personally saw them using some macrophytes, or floating aquatic plants, I should say that. It's easy. People know what macrophytes are. These things that float. They used to make paper. All of these are positive features. I mean, you can literally make money with them. The downside, of course, is the condition that you have to produce this stuff affects the use of the water for other purposes without pre-treatment. Sometimes it's expensive and sometimes it's quite time intensive. So yes, you can use economic models in one sense, in that if you want to just find out how much money or monetary incentive you can have for treating water on the one hand, and then secondly, you have to stand back and look at the broader question. In order to have the economic benefits of eutrophication, what is that going to cost you in regard to other spheres of use? And I guess that's it. I hope I answered the question. I think it's something that requires further analysis. In fact, because politicians, of course, are very keen to this, and if they can show that there's an economic incentive to treat and or use the impacts of eutrophication, I think that they would be pleased to go for it. And I'm certainly pleased that most people would be pleased if things were cheaper because of that. I know my wife would certainly be happy if everything was cheaper, but that's another story. So I hope I answered the question enough. I'll be happy to follow up on it if you think it needs further explanation.
Thank you very much, Walter. Now I would like to invite Claudia and Nava. This is a very precise question, and it's very much related to the information that you already present. The question is presented by Salif and Joseph. And he's asking if mapping is mapping an extension of proliferation of cyanobacteria, if this mapping coincides with important concentration of population in your case in Mexico with the map that you presented. Please go ahead.
Yes, we're monitoring the main places and these places have a lot of population in the most of cases? And the answer is yes. And when we have problems of eutrophication, in most of cases, we have a big populations associated with them.
Thank you very much, Claudia. And now, I think this question will be very, very interesting for Laura Benegas. It goes like this. How do you see proliferation of invasive species, being plants or animals, and the increasing of cyanobacteria, so that sometimes it could end in some regions creating their waters, this very, very strong phenomenon that is affecting other parts in the world? What do you think of this, and what kind of solutions could you propose to this group? So please, Laura.
Yes, you can hear me. So yes, this is a huge problem, and actually we have to think about a combination of technologies and solutions for this problem. And in this case, I will also say that we have to think about the structural limitation of our national economies. We have to take that into account. For example, for the Lake Upacaraí, where I mentioned that there is almost no treatment plants for the nutrient load that will cause the proliferation of different species or invasive species of cyanobacteria. The recommendations of specific effort that the government is investing in sanitation plan, indoor sanitation plans, the recommendation is to have the tertiary treatments, type of treatments, and try to go deeper in the kind of removal of nutrients loads. And this is an interesting investment that we need to think about doing. And also we have to combine with other sources of nutrient load into the lakes and think about, more effort in monitoring processes to actually study better many aspects that we still need to know about these species. This is pointed out also, even if we have a lot of information, there are still things that we need to understand, the dynamics, the process, the internal processes for the nutrient processing into the lake. And that needs to be tackled with innovation. And for that problem, we have the interesting and crucial role of the research community. And just to mention about innovation, for example, the monitoring system of contaminating agents in this lake in Upacaraí has been now starting this campaign that we're starting in 2021, next year, with the water or aquatic drones, for example, to go deeper in the understanding of the processes and the dynamics, and then to understand a better way to solve the problems. Right now, it is not completely understood, and the monitoring is a good way to go, and analyzing the different technologies and the different options to treat the problem and also the sources of the nutrients load that cause this proliferation of invasive species.
Thank you very much, Laura. And now, to conclude this round, I will invite Eduardo Ríos. Could you share with us an example, a successful example of eutrophication addressing? Sorry, I was distracted. I am having some noise over there. So again, could you share with us an example about a successful example of eutrophication control, please? Go ahead.
Yes, thank you, Alejandro. Well, when dealing with environmental problems, it is difficult to describe or a success case, since normally the solutions of the problems are very complex and require a lot of time and improvement of policy and regulatory instruments, as well as promotion and prevention over time, also depending on the scale of attention. The cases that I have known that could have some degree of success cover more immediate objectives of the attention of the problem of eutrophication. So let me share, for example, the case of Lake of Chiragüen. Okay, here it is. So let's share, for example, the case of Lake Chiragüen. The Chiragüen Lake Basin in Michoacán, Mexico, has undergone changes in its natural condition over the last 3 decades. The problem of the Lake Chiragüen Basin are diverse and complex. On the one hand, the modification in the agricultural production systems. The avocado has increased a lot there. The change in land use and the intensification in its use, coupled with the increase in the population and the discharges of water without treatment. This generates negative impacts on the quality of the soil, water, and the condition of the lake. These drivers generated effects with high loads of nutrients to the Lake Chiragüen, phosphorus and nitrogen. Okay, together with increase of temperature, causes harmful algal blooms, in this case cyanophits, where organisms of the genus of Microcystis. These blooms present a toxic risk for the riverine population and tourist activities, since these organisms produce toxins, microcystins, with neurotoxic and hepatotoxic capacities. The response was a proactive collaboration of scientists of the State University of Michoacán, Universidad Michoacana de San Nicolás de Hidalgo, and this with the national and subnational authorities, producing very variable information for decision making and participation production of an integral watershed management plan with the thematic axis focus on the diminishing of nutrients and the proposal of different measures for to go from the causes from a watershed perspective, and also the viability of products to capture phosphates as the lanthanum activated bentonite. So I think this is, I wouldn't say that this is a success, but it's the beginning of a coordination, a very good coordination between scientists and public servants and authorities from national and subnational. So that could be an example. You can see in that photograph the alga bloom, in the right part. Is a very beautiful photograph that you can find in our working group product that it's in mesco.org page. So thank you very much.
Thank you very much, Eduardo. With this, basically, we are concluding the panel. It has been quite interesting. We have a lot of information from the 4 participants that complements in an interesting way presentation of Sandra Azevedo. In some aspects, what is clear is that the problem is quite spread, not only in America and Latin America, basically in many water bodies all over the world. And we are facing a difficult context, taking into account the pressure of people to continue having food, the runoff generated by agricultural lands, the situation of climate change. And it seems that the problem, at least in Latin America, is not well understood by decision maker and the public, because they don't understand how it is generated, and so they don't see how it could be addressed. In this part, monitoring is quite important to know what changes are happening, and it's also quite important politicians to have access to better access to the studies, the papers that have been prepared, and also the involvement of local population, the local stakeholders, to take to grasp the situation into their hands and to achieve some medium and long-term goals about this. Thank you very much to the 4 of you. Thank you very much to Laura Benegas. Thank you very much to Claudia Nava. Thank you very much, Eduardo Ríos and Walter Rast, for your participation. And to all the participants, thank you very much for your attention and debating and patience with this clinical problem that we have. We hope that these discussions could spark some others because there is plenty of things to do in the months and years to come. For your attention, thank you very much, and please stay tuned with the information for the afternoon session. Thank you very much.
Thank you, Alex. Thank you all.
Thank you, gracias. Thank you, gracias. Thank you, gracias. We'll come back. Thank you.
Thank you, Mr. Alejandro Juárez. On behalf of the organizing committee, I want to show our appreciation to our moderator, Professor Alejandro Juárez, and our panelists, Mrs. Claudia Nava Ramírez, Dr. Laura Benegas, Dr. Walter Rast, and Professor Eduardo Ríos Patrón, for their contribution to the pre-conference virtual event of the 18th World Lake Conference. It's important to mention that Professor Sandra Azevedo has answered your questions in the session chat for your convenience. And now I will pass the floor to Dr. Walter Rast, Chair of Scientific Committee of ILEC, who will make the morning session remarks.
Thank you. I appreciate that. I sent just a couple of remarks I wanted to make here, and you're probably tired of seeing my face, so it's probably good you're able to see something else. I often like to point out something because people don't appreciate these things, and you see this, you see the globe. I hope that's on for everybody. Is that right? Because I think this is probably a good statement for us to remember that all the water on Earth is all the water there is, as far as we know. We spend millions, billions of dollars to send satellites into space and sensors and stuff just to find what on other planets? Water. It's obviously that we need that for human life as we know it. Next slide. And you can, the thing on the left there was at one point when I worked for UNEP, the prediction was, and I think it's probably still holds, that 1/3 of all the people at that time were currently living under conditions of what they call water scarcity. And it was going to increase to 2/3, 2 of every 3 people by 2025 if present water use trends continue. They haven't continued like they were. They've slowed down, but still, it's going to be a problem. The main thing I want to do is on the right side that I stole from the National Geographic magazine. You could put all the water in the world in a gallon jug, and that's a 3.85 liter bottle if you're metric. You can see how much water is liquid, fresh water available for human use, 1 tablespoon. That's pretty amazing when you think about it, but it's not a small amount of water. It's equivalent. I once did the mathematics. If you look at the annual average rainfall and divide it by every person on Earth and divided it equally and give everybody the amount of water, how much water would we have? And I've had 1,000 gallons to billions. And in fact, we'd each have about 1 3/4 million gallons of water if it were equally distributed. That's about more than 4 million liters per year. So it's a lot of water. And as I've said before, most of it exists in standing water systems, lakes, reservoirs, lentic water system, wetlands, lentic water system in general. So if you mess those water systems up and they degrade and deteriorate and are basically ruined, then you mess up a lot of water. And these water systems provide the widest range of ecosystem services to humanity than any other aquatic system, in terms of lakes and lentic systems. Next. Next slide. Sandra showed you some interesting pictures of lake degradation. I've just got a few here we can go through quickly. I don't even have to talk about them. I think they speak evidence. And this stuff just didn't grow up in water. It was on land, non-point source pollution, it rained, and it washed into the lowest points of water around, which are typically lentic water systems. This poor guy at the bottom, I saw him. These are all pictures I took on missions, and looking at the water, I wonder if he's better to leave his hands unwashed rather than try to wash them in that mess. Next. And another thing that's a problem is that people throughout civilization, we build our settlements near, we need to build our systems near water. I mean, we need it. We'd all be dead in about a week if we didn't have it, and then we wouldn't have to worry about any problems, cyanobacteria or our economic interest or Trump or anybody. So that's a factor we have to consider. And as you see here, I don't see any public toilets or anything, so they're right near the water. Next. And these are some pictures I took. In fact, Lake Chapala. This guy at the bottom here, of course, he makes his living taking people's tourists out, and that's one of the ecosystem services the lake provides. But look at what they have to see. And it's not like this all the time. And I've been Lake Chapala when it's very high and flooding, and it's very low where it's not so much water in it. So these things can happen. But this is a consequence of eutrophication, and it's one of the things that will be talked about, this particular problem, in the evening session. So I hope a lot of you are able to go at it as well. All you have to do is turn your systems on at 7 o'clock tonight, and you'll be able to go. Next. And eutrophication. Sandra shows some pretty terrible pictures, but this is a colleague of mine who's standing in water in a lake, a reservoir in South Africa. And you can see the green stuff on his feet. That's algae. And in fact, I think it's probably thick enough you could put a paintbrush in it and paint your walls at home green with no problem. Next one. Now, I thought that was the worst picture I'd ever see of eutrophication until I was in China. And I saw this, waves of algae. And I thought, holy mackerel. And, you know, water is not supposed to be green. It's usually blue. So anyway, next one. And all this is eutrophication effects. And that's why we're going to integrate lake basin management and why we spend so much time about it, because nature can take care of itself. I mean, it's not benign. It has earthquakes and volcanoes and so forth, but left alone, it has its own feedback system. So when humans get in the basin, somebody mentioned earlier in one of our questions, or cyanobacteria near humans, correlated with human beings. And I have to say, yes, because you go into places that are relatively pristine, they're wonderful and beautiful. And why? Because humans aren't there. Once we put humans in, then we get into the big problem, because you don't manage a lake. You manage its basin. That means the people in it and their policies, their institutions, their attitudes, and so forth, and even their water uses. And that's why lakes have been described as a mirror of what's happening in the drainage basin. Often eutrophication, for example, symptoms are a trigger for actions that you wouldn't even have thought about before. It's necessary to go to check it. And that's one of the reasons that we're going into this mainstreaming of lakes, which has become an issue for UNEP in the global water arena. To bring lakes to the attention of things like the United Nations Environmental Assembly, the World Water Forum. We'll be talking about it at the World Lake Conference next year, in Guanajuato as well. So I hate to run you through this so fast. In fact, all of these topics are something I could easily give a semester course on, but lakes are important. We pointed about one problem with lakes in this particular webinar, which is eutrophication and its nutrients. And that's been a problem time immemorial. We had eutrophication long before we had pesticides and before we had organic chemicals and even pharmaceuticals. In many developed countries, when you have old medicine, what do you do with it? Flush it down the toilet. Well, it doesn't disappear. The law of the conservation of matter sends it through treatment plants, and fish eat it. So we're starting to get feminization of fish, all kinds of things that we even haven't contemplated. So I guess that's it. I think this was a good session. I hope you come to the evening one. I'm quite interested, because it's not often you get to hear a talk on what are some of the things you can do because of eutrophication to take advantage of the effects. And this should be another equally interesting session. So thank you. And I'm thank the coordinators and everybody. And I wish you all I can say is in this particular crazy time, take care of yourself and stay safe. Thank you. Bye-bye.
Thank you, Dr. Rast. Now it's time to take a break. Please continue with us. The evening session will start at 7 p.m. Mexico Central Time. And on behalf of the organizing committee, we appreciate our kind audience for your presence and cordially invite you to stay tuned to our following session. Thank you very much. Stay safe and see you soon. Thank you.
18th World Lake Conference, University of Guanajuato, Mexico. November 2021. Governance, Resilience, and Sustainability of Lakes for a Better Society. Keynote speeches, conferences, technical sessions, poster presentations, student workshops, young researchers, and the Kasumigaura Prize Award Ceremony. The conference also includes several cultural activities as well as organized tours to visit the state of Guanajuato's most emblematic landmarks. For more information and registration to the event, visit www.worldlakeconference.ugto.mx. Hosted by University of Guanajuato, Guanajuato State Government, National Water Commission of Mexico, and the International Lake Environment Committee Foundation.